First we will use the factoring method. We can solve it by factoring, and we can also use the discriminant. With the discriminant, what we do is we calculate the discriminant, and then we find the two roots using the quadratic formula. And finally, we will explore a way called completing the square, which I like very much. The second method here is widely used at schools, as long as you know how to use the formula of the discriminant. So let's go on the factoring. So if I have ax squared plus bx plus c, it is equal to 0. I can factor this first part. So we can say ax squared plus bx plus c is equal, factor the a by everything. A factor x squared plus b over a x plus c over a. So far so good. And then we use what we used before. So we say a factoring x plus b over 2a squared minus b over 2a squared. We have this part, and then plus c over a, but this time everything use a as a factor. Okay, so we continue. We can say this is equal to a times x plus b over 2a squared plus, we know b squared over 4a squared. To get this one here, we have 4ac over 4a squared. So we say 4ac minus b squared over 4a squared, correct? So we have this, and if you use the minus sign here now, we can say is equal to a factor x plus b over 2a squared minus b squared minus 4ac over 4ac squared, 4a squared. Okay, so what we can say here is this. We can say this is equal to a factor x plus b over 2a squared minus the square root of all this part. That means square root of b squared minus 4ac over 2a, because square root of 4 squared is 2a. Okay, and this is the square. So if you take the square root of this one and then square it, is now we have a form here called a squared minus b squared. We know that is equal to a plus b times a minus e. This time a is all that and b is all that. So let's see, we get our ax squared plus bx plus c is a factor this part x plus b over 2a plus square root b squared minus 4ac over 2a times x plus b over 2a, let me write my b, minus square root of b squared minus 4ac over 2a. I think you get it. And let's put these together. We can say this is equal to a factor x plus b plus square root of b squared minus 4ac over 2a times x plus b minus square root of b squared minus 4ac over 2a. Okay, this is a product, and to get a product, this is two factors, right? But we are solving ax squared plus bx plus c is equal to 0, meaning a factored x plus b plus square root of b squared minus 4ac over 2a factor x plus b minus square root of b squared minus 4ac over 2a is equal to 0. To make this one 0, any of the factors can be 0. So if we take the first part, we can find that the first root x1 is equal to minus all that. This x plus this is equal to 0. That means x is minus b. Okay. Plus square root of b squared minus 4ac over 2a, and x2 is equal to minus b minus square root b squared minus 4ac over 2a. This is what we are looking for. Now you have 1 and 2. These are the two roots. And as you may notice, before we continue, I'll say that if b squared is greater than 4ac, we cannot get a square root of a negative 1 in R. That means complex numbers already. But then that means there is no root. Okay? So this was the first method called by factoring. Okay? Now let's move on and get to the second method. Okay, this video is going to be very long, you know. Okay, in number 2, we are going to use the quadratic formula. Actually, we have already gotten a good result previously. We found a term. That term was b squared minus 4ac. For the quadratic formula, what they do is they call this one delta, the discriminant. So with this discriminant, this is like something you should remember if you want to solve it this way. So when you have ax squared plus bx plus c is equal to 0, you just calculate delta b squared minus 4ac. Instantly you have to take square root of delta, but we know that if delta less than 0, you cannot take the square root. That means no solution in R. But we will find a solution in the complex system. But when delta is equal to 0, very interesting, that means we have a double root. The root is there but twice, only one root. And finally, the most interesting case, when delta is greater than 0, we have x1 and x2, two roots. So depending on the situation, we are going to have no solution, one root or two roots. Okay, but we already seen that x1 was equal to minus b plus square root of delta over 2a, and then x2 is equal to minus b minus square root of delta over 2a. So these are our two roots using the quadratic equation, okay? Quadratic formula, I mean. Completing the square in number 3. This is really similar to our factoring method. Only difference is we have to isolate c over a. So let's dive into this. So if I have ax squared plus bx plus c is equal to 0, first I say I divide everything by a. So x squared plus b over ax plus c over a is equal to 0. I move the c over a to the other side, becomes x squared plus b over ax is equal minus c over a. This is something we know already. We get x plus b over 2a squared minus b over 2a squared is equal to minus c over a. And we move the h term also to the other side. So we say x plus b over 2a squared is equal to b squared over 4a squared minus c over a. Okay, we keep going. We have to put this on the same denominator here. So we have x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. And we can say that x plus b over 2a, taking the square root of both sides, is equal to plus minus square root of b squared minus 4ac over 4a squared, correct? That means x is equal to minus b over 2a plus minus square root b squared minus 4ac over 4a squared. Or if we break, we can say square root of b squared minus 4ac over 2a. So in this situation, we have only one formula. So x1 will be plus, x2 will be minus here. So as you notice, the three methods end up being the same thing. So it is up to you to choose which one is best for you. But completing the square is an elegant method. I like it very much. And this is what we are going to use in the practice. Now let's move on and add a few items before we close this long video. To complete this video, let's talk about the relationship between the two roots. This is very important. So sum of roots. If as an exercise you calculate the sum of these two roots, x1 plus x2, you end up getting the value minus b over a. This is very important and should be remembered for exercises, okay? This is something you should put in your mind when you are solving quadratic equations. And when you take the product of the two roots, you can demonstrate that if you want, or go to my site to see it. You can say x1 times x2 is equal to c over a, okay? that is product, of course. And the final touch here is when we are factoring a regular ax squared plus bx plus c, it's always good to break the b here, break the b in two values that add up to b. Sum is b with product AC. So these are the techniques we are going to use when we do our calculations. So I would like you to pause the video and write these formulas. The sum of the roots is equal to b over a, product of the root is equal minus b over a, product is c over a, and when we are factoring we have to break b in such a way as to get two numbers that add up to b, and they have the product of a times c. The next video in these lectures will just give us the chance to see how these work. Again, thank you for watching, and see you for the next video. Bye.